Hi guys, welcome back to my YouTube channel. In this video we're going to learn how to georeference a scanned map. What you're seeing here is a scanned topographical map of Lokichokio area in northern Kenya. So this is a scanned map which is for a very long time. Anyway, the point is when you're georeferencing, you're trying to make it possible for you to extract features in such a map, which is just an image for now. But if you want to use it for your analysis, you want to extract features here so you can use it for something else, or you want to digitize these features, you first need to connect this map or these features to its true coordinates. So to do that, you need to georeference, and this is what we are going to do in this map. So first, let's visualize what we have in this map, and you can see different kinds of features. We have these bushes here, and you can see different kinds of boundaries like this one here, and down here we have the legend which shows us what each kind of symbol represents. We also have this area here which is very important, indicating the coordinate reference system of the map. So we can see that the spheroid is Clark 1880 and the projection is transverse Mercator. We can see the poles, eastings and the northing, and on the grid labels you can be able to tell the coordinates of each feature. Like here, the corner points, we have the latitude, longitude indicated, which we are going to use in our georeferencing process. So what we are going to do is first we need to ensure our georeference plugin is activated. So when you go to plugins, you can search for it. You search for georeference. You can see mine is already activated, so if you turn it off, you can just tick off the tick. You can see it was right here, but when I turn it on, it's back. And also another way to access it is going to raster and then georeferencer. So this is where we do our georeferencing. Now the first step is to add your image. So this icon here is for open raster, so we go to our image, which is the Lokichokio image, and then we open it. This is our image. Next point is for us to add the ground control points, which are the true points on the ground. So that's what it's going to help us relate this image to the ground coordinate system. So first, identify the points in the image where you can use as your ground control points. It's very important to ensure they are distributed around the map, and also the number of the ground control points you're going to use is dependent on the accuracy of your scanned map. If it's very accurate, you don't need so many control points, but if the accuracy is a bit low, you might need more control points. So depending on that, you will choose how many control points you need, but using at least 3 is okay. Also in this video, I'm going to use the corner points, because in the corner points, that's where they've indicated the coordinates here in this map. And if I zoom in, you can see like this corner point here, you can see it's 4 degrees north and that 4 degrees east. So those are the geographic coordinates. And so our first step is adding the control points, and I'm going to use the 4 corner points as my ground control points. So this button here is for adding control points. So I use it to zoom into your area like here, and then you click, and then this pop-up will appear, indicate your easting and northing, which in this case my easting is 34 and my northing is 4 degrees north. Then you just say okay, and when you do that, this point here will be added to the table. But okay, I already have some coordinate points which I had already added, so I'm just going to load it. And there is this tool here, you can load your ground control points. So I'm just going to load it, and you can see I have these 4 points here. So when I zoom out, you can see the corner points, 1, 2, there are 4. You can use these tools here to navigate around the map. So you can see I have 4 control points, and these are the details, the source, XY, and the destination. And So after you have your control points, so now I have 4 control points, what you need to do is to set your transformation settings, which you go to settings and transformation settings. So you can just click on this icon here, and here we indicate what is the transformation type that you want to use, which is going to transform the source XY to the destination XY, and what is the target coordinate reference system and the resampling method. So you choose the transformation type based again on the accuracy of your scanned map, and then I'm going to use the polynomial one, which is the usual one. But let's say if your data has a very low accuracy, you can use like the thin plates plane method. So you click on this icon here to indicate your coordinate reference system. So from the map, we've seen that they use the Clark 1880 datum. So we are going to choose on a CRS, that is a coordinate reference system that uses the Clark 1880 datum, and based on these results, we are going to choose on the one that has ARC, because you know mostly in Kenya we use the ARC 1960 datum. So I'm going to choose it and say okay. So that means that my final coordinates are going to be in this coordinate reference system, and you need to ensure that you take the option of loading it in QGIS when it's done. So when we have georeference, we can be able to visualize our output raster now, which will be georeference in QGIS. So now you can indicate your output raster, which is not important right now, or let's name it Lukchokyo georeference. Then you just say okay. So now we are ready to georeference, and you realize there is a change here in the dxdy after indicating your transformation system. And the final coordinate system. So you can see my residual is at 1.7553. So it's good to try and ensure that it comes close to 0. Anyway, so we are going to deal with that later. So now that we're ready, let's click on this button here which says start georeferencing. So you can see it's done. Now we can go back to QGIS and see how it looks like. So we can close this, and you can see we have the Lokchokyo georeference. It's on. Let's zoom to it. This is it. So to verify that your georeferencing was accurate, you can add a base map to see if it coincides with the real area where it's supposed to be. Like this one, it's supposed to be in somewhere near Turkana area in Kenya. So I'm going to turn on my base map, which is here, OSM standard, and let's adjust the transparency levels of this map so we can see both the base map and the map. So you can see, so like you can see this here, I think it's a road. It's coming like that, and it's joining just smoothly to the road in the map, which is good. That means our georeferencing was accurate. You can also see this boundary here also, it's just joining smoothly. Same case to this reserve here, you can see it's joining smoothly, the boundary, everything is joining smoothly. So that's good, it means you georeference well. So that means we can now start digitizing features here. Everything is joining in smoothly. If If I turn off our image, you can see the ground, you can see the airport. When you turn it on, it's like nothing has changed. They're both coinciding well, so that's a good thing. It means you've georeferenced accurately. So that was the goal of this lesson. I hope you've learned a lot, and we'll see you in the next lesson. Thank you.